Hello everyone, it's me Yuliana Usman, a civil engineering student at Diponegoro University, and in this video I would like to explain and present to you guys an assignment of mine from a subject in my major called value engineering. And in this task I was assigned study case number 5. It's Intermodal Transit Center, City of Hercules at San Francisco, California, United States. So, if you want to know, value engineering, it's some kind of study that was implemented through some project before the project was started, and they want the purpose of the value engineering, they want to reduce the cost without reduce the quality and keep the same performance of and function of the project itself. So I think the assumption that I could make, value engineering is important, especially for a big scale of project. You can see Intermodal Transit Center, it's a big scale of project from the title itself, right? Okay, so I'm gonna start my presentation. First thing first, I'm gonna show you the project description. This project called Intermodal Transit Center in City of Hercules, San Francisco, California, with the purpose of the project is to increase the local and regional mobility and transportation option by providing new and expanded service, a transit service with intermodal connection that will encourage use of public transit. This is the main problem where people these days they don't want to use the public transit. Even in my country, myself, Indonesia, they don't really want to use the public transit. I mean, like imagine if many people use the public transit, they could use some the traffic jam issue and then along the road, right? Okay, the need for the project is driven by the resident of the San Francisco Bay Area who depend heavily on region-wide and trans-Bay commuting option. Despite the use of existing public transit service, particularly rail and buses, of course, this is the main public transport that they use, the rail and buses. Traffic congestion continues to increase, affecting hundreds of thousands of Bay Area residents and creating both economic and environmental costs. The severity of congestion will increase in the future as population and employment in San Francisco Bay Area increases. That's why they need to build this intermodal transit center, because okay, many people will come, this the they will increase in the future, the population will increase. Okay, let's take a look. The proposed project, the three main point here is: first, they need to construct an intermodal transit center or ITC. Second, they need to associate roadway improvement, and they kind of need to build ancillary facilities throughout the intermodal transit center. Okay, this ITC includes pedestrian access to the existing Union Pacific Railroad or UPRR line, and a newly constructed passenger platform. Although train service would be available throughout most of the day, the facility is expected to be used mainly by commuters traveling throughout the San Francisco Bay Area. Train passenger would be able to either walk from nearby residential units, bike along the bicycle path connection that is part of the proposed project, or park the motor vehicle in the park and ride lot that is part of the proposed project, of course. Transit center patrons will also be able to access this site via public bus service that will be extended to the proposed Hercules ITC as part of this project. Additionally, the facility would be designed to accommodate potential future ferry service. Okay, this is the future project. Okay, let's move on. For the value engineering project analysis, the scope study, the study first transit loop drive, including Creekside Park. You can see through the picture to the Google Maps. I mean, like this is a Google Maps. When they were going to construct this project. And then there's the railroad. There's some great separation and realignment of a portion of the existing UPRR tracks, including construction of rail platform, retaining walls, and a bridge crossing Refugio Creek and utility relocation. Okay, there's also the station building number 1, 2, and 3. There's also the Bay Trail you can see at the maps. This includes the East Bay Park Regional District Trail along the shoreline from Pinal Trail to Victoria, by the way. Okay, when they did this study, they go to the site study, they get some tasks, that some constraint and controlling decision that they need to make when they're going to analyze, they're going to study the value engineering. First, they need to stay within the footprint of the draft Hercules ITC Environmental Impact Report, or EIR, and then design for the train ferry center platform station area. Pedestrian overcrossing and connection to the ferry is at 60% design. The design was recently modified to reflect the waterfront initiative waterfront warehouse criteria. Public workshops have taken place to receive feedback to the station and tower design. 60% design drawings for the track, signal, retaining walls, and center platform are nearing completion. Consultants are simultaneously working on the following: refugee creek straightening and restoration plans, John Muir Parkway Phase 2 and Bayfront Bridge design, and bus facilities and access via transit loop drive bridge. There's too many constraint and controlling the issues in that the VE team needs to make here. Okay, let me continue. Bicycle and pedestrian access to the ITC via the Bay Trail and connection via John Muir and San Pablo Avenue Sycamore to the Ridge Trail will be a key component to this project. And LEED, or Leadership in Energy and Environmental Design standards, are being incorporated throughout the ITC and the surrounding development, including the possibility of small and wide turbines on the platform and solar panels on the center platform roof structure. Okay, construction will start on the retaining walls and utility relocation in the second quarter of 2010, bearing on any anticipated delays. Okay, the value engineering team got some issue, the project issue, when they do the observation. First, plans for a plaza cafe building on block 1, the location of the access to the station, are under discussion. It's for the phase 2. And also, a community facility will be located across the street from block 1 at block 3, adjacent to the ITC facility. Okay, they need to put this through when they going to redesign. Okay, so that they won't face any problem in the future when they need to construct this project. I mean, like, the project will already constructed. I mean, the time while they're doing this observation, and also there's a lot of earth to move or surcharge. Railroad signals could conflict with shoe flight. There's no drainage issue seen because of surge and overburden. More curvature of tracks than observed on maps. Okay, this is the main issue when we need to construct a transportation project, because the thing on Google Map, always give us, you know, not a detail. I mean, not a detail, wrong information, especially about the curvature, about the land, something like that. It could be an issue for railroad flagging. Okay, and then there's importance of connecting the belt trail for all the residents living in the area. And there's the need to construct John Muir Parkway to use a haul road. Then the location of the gas line appeared to be a big roadblock. The sewage lift station needs to be moved early on too. And then they ask themselves, do we need to use soil nail walls and access across railroad tracks to construct soil nails? So there's these many problems that are issue that they got through the observation when they want to study the value engineering analysis. They need to take this into the consideration. They need to fix this so that there won't be any problem when when the contractor, when the project will build. Okay, so the value engineering team, when they do the project analysis, of course they use the tools for value engineering. Okay, this three is the most common thing in the value engineering study. First is the cost model, the functional analysis, and the fast diagram. Cost model. Okay, before, of course, we need to know the cost model. I mean, like, how do we know the how do we how we can to reduce the cost estimated if we didn't know the cost? Okay, of course we need to model the cost. As you can see, the train station accounts for 32.3%. I think if you guys look through the paper, I mean the document for the bill engineering, you could see and you can find the details for the model, for the cost, for the estimated cost for this project. The train station is the most highest one. I mean, like, that is the most take part of the cost. And then the retaining walls 26.6%, re-enrolling railroad over 8%, relocating the gas line and fiber optic almost 8% of the project total. This four is the highest one. Of course, they need to choose this four because when we're going to analyze the cost, of course, we use the item that cost the most. Okay. Next is the functional analysis. They want to analyze the function of each item in the project, the transform project elements into function, which move the VET mentally away from the original design to takes it to what the functional concept of the project. Function are defined in verb noun statement to reduce the needs of the project to the most elemental level, identifying the function of the major design consideration of the alternative ways to accomplish the function. They need to do this kind of analysis. And then the fast diagram. The fast diagram is show move people, because this is intermodal transit center. Of course, the objective is the project, they want to move people, so that's why the move people is the basic function of this project. The key secondary function includes access transit, provide connectivity, guide people, and give shelter. This provide the VE team with an understanding of the project design rationale and which function offer the best opportunity for cost and or performance improvement. Of course, they need to take this into the consideration. Okay, after they do the study by well considering all the elements, all the items, all the point that I was said that I have said before, they can generate the idea and they can evaluate it. And in this project there are over 75 value engineering ideas were generated by the VE team. They were generated carefully evaluated based on the project specific attributes and the supporting function. The ideal list was grouped by function or major project element. The team compared each of the ideas and then which concept attribute define whether it was better than or equal to or worse than the original concept. Of course, they want the better one, not the worst one. There's no point of value engineering if they choose the worst one that than the original concept. The team reached a consensus on the ranking of these ideas. Higher ranked ideas were developed further, lower ranked ones were dropped from further consideration. Of course, they will rank from 1 to 75 of the ideas. Of these ideas, they choose 11 of it to implement, because what that is the most significant both in cost saving measure as well as operational impacts. So that the the best scenario could be both. Okay, the next explanation I would like to explain to you guys. From the 11 ideas, I choose four of it to explain to you guys. So how this value engineering could reduce the cost estimated. I'm gonna show you guys. Okay, the first is the value recommendation number one. They want to realign the railroad, remove the shoe fly. Okay, the original concept, it's as shown the 60% plan set. Original concept constructed double track shoe fly, shifted trains traffic to the shoe fly, and then constructed new railroad bridge on the existing MT1 and MT2 main tracks. But the value team recommended that the Union Pacific Railroad construct the new bridge and the traffic using armed forces. Once the new bridge are placed in the new MT3 track is contracted in its final alignment, you can see the change, the different here. There's existing MT1 and MT2, but on the value engineering team recommendation, there's a new MT3 track. Of course, they need they need UPRR to assign this. Okay, the advantage from this recommend idea number one, they can eliminate the shoe fly tracks, eliminate shifting of first shoe fly 5 to final alignment by constructing empty three track through station in final alignment. They also allow construction of retaining walls through station, extend future main track, reduce construction contractor closing life main tracks, and simplify the construction staging. Allows for other costs. There's many advantages you can see, and you can read one by one here. But let's move on to the disadvantage. Of course, it require UPRR to agree to build railroad, because this is their field of job. Okay, they need UPRR to agree to build the railroad. with their own forces. And then there's a potential schedule constraint. Okay, because well, they need to build a new MT3 tracks. Of course, there's a potential of schedule constraint. And then limit works area and clearance while constructing station building. Number three. Okay, building number three, there's limits work area. And also a second station bridge would have to be set over MT1 and MT2 tracks. Okay, as for the cast summary, the concept is about 5.78 million with the net saving of zero point 0.5 millions. Okay, they could reduce some zero point 0.5 million. It's not a small amount of money, okay? Okay, value engineering recommendation number two, it's about the retained earth. Okay, original concept, they want to use the pile support cantilever retaining wall along bayfront project area. But the value engineering team recommended they could build some ground improvement with MSC or segmental block. Well, you can see in the picture, they want to use the ground improvement using the segmental block. Well, this is the, you know, the design. You could use the reinforced soil here. This is the foundation soil here. Okay, the design height. Okay, the design height here. If you want to know the detail, you could take a look at the document. Okay, let's move on to the advantage. You can reduce cost, reduce construction time, ease of construction, eliminate piles, maybe better able to match other aesthetic elements, texture, and color of other features in the project. But the disadvantage here is that potential interference conflict with pipeline relocation. Of course, if they want to build some these retaining walls, there's some conflict with the pipeline relocation. Of course, they need to take this into the consideration because it might cause a big trouble, a fatal to the project, and then it requires increased coordination with the utilities. So they need to be careful of this. Okay, let's take a look at the cost summary. I mean, like this disadvantage is a high risk, but look at the cost summary. The recommendation concept before at the first place, it's about 11 for $5.57 million, while the recommendation concept it's only cost about $3.28 million. So they could use the net, so you can see the net saving it's about 10.0 $10.3 million. Okay, value recommendation number three. The original concept, they want to build a wide promenade between transit drive to accommodate loading or unloading, belt traffic trail and belt trail traffic and mindering pedestrian. But the recommendation from the value engineering team, they want to decrease width by having upper portion of grade change to be a slope, or by having a grade difference between promenade and EBRP trail with slope or step between. Okay, you can see the figure. First, the original concept, they want to use this. It's just a straight line here. People walk here for loading and unloading people around, well, things and people around here. But look at the new one. Look at the new one. They want to propose this design where they're going to decrease the width and then they add up some stairs here. So it's quite aesthetic if you can see here because there's and stair. So yeah, it's a structure. Yeah, it's a structure issue. Look at the advantage. It's reduced cost. It simplifies works. Adds a potential for more vegetation. Yep, you can make some vegetation around here, and it's quite aesthetic for it. It's a transit center, and expand view while seated. People see while waiting for their train, buses, or other transportation. They could enjoy the view. But look at the disadvantage, they reduce width of promenade. Of course, when they reduce the width, the structure is not as strong, but I think it's the value engineering team will take into consideration the as for the strength of the wall, so that it could be a better kind of walls. And then max gathering space loose, drainage challenge. So it's a new challenge for the value engineering about the drainage. There's a possible issue with grade separation. Okay, there's a grade separation here because they use stairs here. there's a possible issue, but I don't think that's it's a big problem for for the grade separation. Then they may require additional ADA RAM, may have great conflict with transit loop and bridge. The net saving is about $0.05 million. It's not as big as the recommendation number one or number two because of what? It's just they only reduce the width and then they add up the stairs, so it's not that much, but I think it quite important too. Okay, let's move on to railing recommendation number five. It's quite unique from any others ideas. The original concept, they want to use the guard rail tempered glass panel with 1.5 times half inch steel bar post, but the recommendation team recommendation, they propose two different guardrail. Option A, they replace the guardrail with steel cable guardrail. Look at the picture for option A. And with the option B, they want to use at a ram outside gauge, widen ram to eliminate gap between ram edge and structure. They eliminate the glass and stainless steel guardrail. They keep the stainless steel tube with diameter handrail, and then ram width doesn't change. Ram width and the ram edge of ram guardrail to remain at range bridge level interface at the interior edge of RAM. So we couldn't provide you guys with a picture like this for the option B. But if you can imagine, if you take a look carefully on this is the guardrail. Uh, okay. The Take a look at the advantage. They can reduce the cost, eliminate need for guardrail in some areas, simplifying installation. Look at the disadvantage may have aesthetic implication if the architect was looking for floating RAM structure, and that is complex detailing implication where slope RAM structure interface with bridge and will increase complexity with cleaning and reglazing of window. Okay, let's look at the cost summary calculation. It's option A, about 889,600 dollars. Option B, 97,760 dollars. Need to verify. The total is about 4,098,560 dollars. Okay, the recommendation concept is about $0.89 million. Recommendation concept $0.5 million because they choose the option B. So the net saving is about 0.48. Look at the different here from option and option B. Of course, clever people will choose the option B. Okay, the last one is the conclusion. There's the conclusion that I could add up to here. It's the first of the 75 value engineering ideas were generated by the value engineering team, and 11 of them were chosen and implemented. Number two, there are three tools that are used through the whole process of value engineering study, which is cost model, function analysis, and the fast diagram. And the total net saving cost of the whole project are $13.06 million. It's a big amount of money they could reduce through the process of the value engineering study. And of course, it is a good thing. It gives the advantage for the owner, consultant, and the contractor, and all the people and the stakeholder in this project. It's a big project actually. So I think this sum up to here. As for the other recommendation, I mean other from 11 others recommendation that are implemented, you can find it on the documents itself, because I don't think it's I could explain to you guys all of them. So really thank you guys for watching this video, for listening to my presentation. I'm really sorry if I can't explain to you guys better, but I hope this video could teach you, could give you more information about value engineering. You could understand more about value engineering. Thank you for watching, thank you for listening. Goodbye from me, Yuliana Usman. Bye.